Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is about identity equation. Last episode, we already studied what equations are, and I've mentioned these three conditions so we can say that it's an equation. First, equation has an equal sign. Second, equation has variable. And lastly, equation can be true or false regardless of the values of the variable. How about if an equation is always true regardless of the values of the variable? That is what we call an identity equation. Let's give an example. 2x plus 1 is equal to x plus 1. Let's say value of variable x is 2. So 2 times 2 is 4 plus 1, 5. 2 plus 2 plus 1, it's also equal to 5. How about if x is equal to 3? So 2 times 3 is 6 plus 1, 7. 3 plus 3 plus 1, this is also 7. Okay, let's say x is equal to 4. So 2 times 4 is 8 plus 1, 9. 4 plus 4 plus 1, this is also equal to 9. So this equation 2x plus 1 is equal to x plus 1 is an example of an identity equation. This equation is always true regardless of the values of the variable. Okay, if we're going to look at this expression to this left side, 2x plus 1, this is equal to this x plus 1. Like terms, x plus x, 2x plus 1. So 2x plus 1 is equal to 2x plus 1. So these expressions on the left side and on the right side are equal. So it's an identity equation. Okay, if there is an equation that is always true regardless of the values of the variable, how about an equation that is always false regardless of the values of the variable? Okay, yes, we have an equation like that. So in this equation, 0 times x is equal to 1. Okay, remember, any number multiplied by 0, the answer is 0. So if x is 1, 2, 3, 4, so regardless of the values of x, this number on the left side and on the right side are not equal. So it's always false regardless of the values of the variable. But this equation doesn't have a name. Okay, so when we say identity equation, okay, regardless of the values of the variables, this equation is always true. That means the number or the expression on the left-hand side is the same or equal to the number or expression on the right-hand side. Okay, let's check these equations here. So which of the following equations is always true regardless of the value of x? Okay, we are not going to substitute values of x here because these are many. So what we're going to do is we will compare the numbers or expressions on the left side and on the right side. If same or equal, then that is an identity equation. So here, 3x, this is 2x, this is 2 and 3. So this is not an identity equation. Okay, how about here? 3x plus 4x, like terms. So this is 7x. 7x is equal to 7. This is not an identity equation. 2x minus 6 is equal to x minus 6. This is 2x and this is x. So this is not an identity equation. Okay, how about here? Negative 2 times x minus 2 inside the parentheses is equal to 4 minus 2x. So we can compare these two expressions. We have to remove the parentheses, and we can do that by using distributive property. So negative 2 times x and negative 2 times negative 2. So this is negative 2x plus 4. Okay, negative 2x, this is also negative 2x. Positive 4, this is also positive 4. So number 4 is an example of an identity equation. How about number 5 equation? This is positive 6. Okay, positive 6. This is negative 3x, but this is positive 3x. So this is not an example of an identity equation. Okay, now let's answer this simple activity. Find the value of a plus b when the equation ax minus 3 is equal to 2x plus b is the identity for x. That means this expression ax minus 3 is the same or equal to 2x plus b. Okay, note that a and b here are constant numbers. Okay, we are going to find the value of a plus b. Ax minus 3 is equal to 2x plus b. So that means a is equal to 2 and b is equal to negative 3. So a plus b, 2 plus negative 3, this is equal to negative 1. So the answer is negative 1. Let's move on to the second problem here. When the equation negative 2 times this expression 3x minus 6 plus 2 is equal to ax plus b holds regardless of the value of x. We will find the value of 2a plus b. Regardless of the value of x, that means that this expression is equal or the same to this expression ax plus b. Okay, so we are going to find the value of 2a plus b. Okay, but before we can do that, okay, this expression inside the parentheses must be simplified first, or we need to remove this parenthesis so we can compare easily. Okay, so what we need to do is we need to use distributive property so we can remove the parenthesis. So negative 2 times 3x is negative 6x. Negative 2 times negative 6 is positive 12. So negative 6x plus 12 plus 2. And this is equal to ax plus b. So this is negative 6x plus 14. This is equal to ax plus b. Again, this expression is equal to this expression. So that means a here is negative 6. So a is negative 6. And b is 14 or positive 14. So we will find the value of 2a plus b. So 2 times a, which is negative 6, plus b, 14. So this is negative 12 plus 14. So our final answer is positive 2. Okay, let's take a look at this third problem here. This one is for you to answer. So which of the following is an identity equation? Okay, so in order for you to find out which is an identity equation, okay, compare the expression on the left side and the expression on the right side. If totally the same or equal, then that is an identity equation. But for those equations that has parentheses or expressions inside the parentheses, okay, so you can compare, or in order for you to compare it properly, you have to remove the parentheses first using distributive property. Okay, you may write your answer in the comment section.